Hello everyone and welcome to Just Solved It. Today we will be discussing or actually solving a problem through the Simpson's one-third rule. We will be approximating the value of the integral x squared plus 3 with the limits 1 to 4. The same example as we have used in the previous method of approximation, the trapezoidal rule, which you could check out right now on our playlist. So here on the Simpsons one-third rule, we have this condition that the n must always have an even value. So it's just proper that we have the n is equal to 4. Still, in scope for the Simpsons one-third rule. So as you could notice, the difference is that here's the one-third, which is the difference between this and the trapezoidal rule. Trapezoidal rule, we have this 1/2 or over 2 multiplying with the rate of change. Here we have this one-third. And then after that, we have this function of x sub 0, okay, plus 4 times f of x sub 1. We have this coefficient of 4. Then the next term, we have this coefficient of 2. Again, 4. So these coefficients of 4 and 2 are just alternating. So starting from the second term with the coefficient 4, afterwards in the third term, we will have the coefficient 2. Fourth term, we have this coefficient 4, and so on, until we reach the last term, f of x sub n, which is also the same as the first term with a coefficient of 1. So now let's solve it. Okay, so the rate of change in x is b minus a over n. Substituting the limits, 4 minus 1 over the value of n, which is 4. 4 minus 1 over 4 will be giving us 3/4. The same way from the previous method, we have this x sub 0 is equal to 1 here. We divide this part into 4 parts actually, which is given by this n is equal to 4. Each parts have a value of 3/4 or have a magnitude of 3/4. If this is horizontal, obviously we have this rise over run, so the run is 3/4 long. So 1 plus 3/4, we have this 7/4. 7/4 times actually plus 3/4, we have this 5/2, and so on until we reach the upper limit of 4. So we have these values. Substituting these values into this formula, we will be having this 3/4 over 3 times f of 1 plus 4 times f of 7/4 plus 2 times f of 5/2 plus 4 f of, okay, we have this f, okay, so 4 times f of 13 over 4 plus f of 4. As usual, if we have this value of f of 1, this is our f of x. So substituting the value of 1 into the variable x, 1 squared plus 3, will be having an answer of 4. Here, substituting the value of 7/4 here at the x, so 7/4 squared plus 3 times 4 will be giving us the answer 97 over 4. So the same procedure we'll be doing in the rest of the terms. So we have these values now. So operating the value, the equation 4 plus 97 over 4 and so on times 1/4 will be giving us an answer of 30, which is the actual answer of these integral given to us if we solve it using a scientific calculator. So this answer doesn't give us any errors actually, which is really good, what we really need in solving problems. I don't know if this applies in all of the integrals that will be given to us, but in this example that we have worked with, it gave us an answer without any errors. That's the Simpsons one-third rule, and I think we have just solved it.